All right, today we're going to continue learning about bivariate data, and we're going to look at what we call two-way frequency tables. So your learning target for today is I can instruct and interpret data in a two-way table, and I can use this data to describe possible association between two variables. So what you're going to do is watch this video and take notes as you're watching. Remember, pause, rewind, go back and rewatch this video as much as needed. You should have a copy of this in your Google Drive so you can watch it whenever you need to. When you're finished with this, there is a discussion post on eClass that you need to answer, and when you do that, make sure that you answer every part of that discussion post. All right, so what is a two-way table? A two-way frequency table is a table that shows the frequency of data that's categorized in two ways. So when you look at this frequency table, you see it's comparing people who own dogs to cats. Well, this number here, this 6, this is 6 where someone owns a dog and also owns a cat. 5 people in this category own a dog but don't own a cat. And out of everyone surveyed, 11 people own a dog. In this one, there are 3 people who own a cat but do not own a dog. And in this one, there are 11 people who don't own a dog and do not own a cat. So altogether, there are 14 people who do not own a dog. You can also look at it horizontally. So in this case, there are 6 people who own a cat and a dog, and there are 3 people who own a cat but no dog. So there are 9 people who own a cat. In this case, there are 5 people who own a dog but no cat. There are 11 people who own no dog and no cat. So there are 16 total people who own no cat. And then the total number of people surveyed. Well, you should be able to get that from 2 of these. So you should be able to get there are 9 plus 16 people, so there are 25 people, or 11 plus 14 people, and there are 25 people. So what you end up seeing in all of these is that all of these rows and columns will all add up to each other. Now, there is a difference between a two-way frequency table, which is this, what we just looked at, and a two-way relative frequency table. So we'll talk more about a relative frequency table tomorrow, but what you need to understand about it is that with a two-way frequency table, what we just did, that shows you the total number of people who were surveyed. So in this case, there were 25 people surveyed. This table over here is giving us the exact same information, but it's giving us relative to 100, which means it's giving us the data written as percents. So in this one, there were 6 people who owned both a cat and a dog. Well, that means out of everyone surveyed, 24% of people owned both a cat and a dog. All right, so some important vocabulary that you need to know. The first one is frequency. And when we say frequency, we mean the number of times that an event occurs. Also, a two-way table is a table that shows the frequency of data that's categorized in those 2 different ways. All right, joint frequency and marginal frequency. Those are terms that we're going to explain more in depth tomorrow. But joint frequency is found by dividing any number that's not in the column total or the row total by the grand total. And marginal frequency is found by dividing any number that is in the column total or row total by the grand total. And I know it's okay if that doesn't make a lot of sense to you today. It will after tomorrow. All right, so let's look at some two-way frequency tables and see what information we can get from them. So the first example here says this data shows the eye and hair color of students in Mr. Hopkins' 3rd period civics class, and we're going to use the table to answer the questions. Well, when we look at all of our rows, it's blue, brown, green, and hazel. Well, that means this looks like these are probably eye colors. And then in my columns over here, I have blonde, brown, black, and red. Well, these are probably hair colors. So what I'm going to do is answer all of these questions. And the first question says, is this a relative frequency table? Well, if I want to know if it's a relative frequency table, I'm going to go to the total. The total, in order for it to be a relative frequency table, needs to be 100 or 1. So it can be either 100 or 1 whole to show me that it's showing 100% of the data. In this case, because the total is 22, this is not a relative frequency table. This is just a regular frequency table. So no, we would say this is a frequency table. Now, B says, how many students have brown hair? Well, this is my hair color. So when I find the one that says brown, well, if I look, there's one person with brown hair and blue eyes, 6 people with brown hair and brown eyes, 1 person with brown hair and green eyes, and 2 people with brown hair and hazel eyes. And that is a total of 10 people who have brown hair. So there are 10 students with brown hair. Then it asks how many students have green eyes. Well, this is my eye color. So when I look at green, there are 2 with green eyes and blonde hair, 1 with green eyes and brown hair. Nobody has green eyes and black hair, and nobody has green eyes and red hair. So for green, there is a total of 3 students who have green eyes. The next question asks how many students have brown hair and brown eyes. Well, let's go to where we have brown hair, and let's find where we have brown hair and brown eyes. This is brown hair and blue eyes, so that doesn't tell me anything. This is brown hair and brown eyes, so this is what I'm looking for. Well, in this case, there are 6 students who have brown hair and brown eyes. Now, the next one asks, what percentage of students have blonde hair and blue eyes? Well, this is asking for a percentage. Well, the first thing I need to know is how many students do have blonde hair and blue eyes. So I find my blonde hair and then match it with blue eyes. So there are 4 students that have blonde hair and blue eyes, but I need to find the percentage. So I know that there are 4 who have blonde hair and blue eyes, but that is out of 22 total students who were surveyed. So to find the percent, I'll do 4 divided by 22, which actually gives me 0.18 repeating. And then if I want to make that into a percent, I would move my decimal or multiply by 100 or move my decimal 2 places to the right, and that would give me 18. And remember that behind that decimal, that 0.18 still repeats. So it would be 18.18 repeating percent. Now for my next example, you'll notice this is a little bit different because in this example, my table's not completely filled out. So in this example, I actually have to fill out the table based on what I know. So what I'm going to do is look for anywhere, either a column or a row, where almost everything is filled out, but not quite. And the first one that I can see pretty easily is right here in the total. Well, what I know is that there are 106 total students in 10th grade, 72 total in 11th, and 54 total in 12th. What I don't know is how many are in 9th. Well, I also know that there are 400 total students that are enrolled in language classes. So to figure out this part, I'm going to do 400 minus 54, 72, and 106. You also could have done 400 minus, and you could have gone ahead and added up 54, 72, and 106. Either way, you're going to get the exact same answer. So when I do that, I get 168. So I know that there are 168 ninth grade students here. Now, from there, if I know the total is 168 here, if I look at this row, I can figure out how many ninth grade students take Spanish. I know that there are 168 total students. So again, this time I'm going to take my 168, which is my total, and I'm going to subtract 0, 14, and 71 to figure out what I'm left with. And when I do that, I get 83. So there are 83 ninth grade students who take Spanish. Well, once I have that, I can look and see, okay, what can I do next? Well, it looks like I can figure out this number because I know that there are 155 total, and I know all but one of them. So again, if there are 155 total, I'm going to subtract. I have 83, 46, and 12. And when I subtract all of that, I'm left with 14. So there should be 14 here. Well, now that I know this, I'm going to look and see if that helped me out anywhere. And it does. I can figure out now what's left here. I know that there are 54 total 12th graders. And I can figure out what goes here by doing 54 minus 14 minus 9 minus 18. And when I solve that, I get 13. So that means there are 13 12th graders taking French. Now I can use that 13 and I can fill out this part. So in this part, I know that there are 137 students taking French, and I need to figure out how many of those are in 10th grade. I'm going to do 137 minus 71 minus 19 minus 13. And when I do that, I'm left with 34. So there are 34 10th graders taking French. Well, from here, it looks like I can figure out how many 10th graders are taking German. So again, I know there are 106 total. I'm going to do 106 minus 46 minus 34, and then minus 4, and I'm left with 22. From that 22, it looks like I can figure out how many 11th graders take German. So I know that there are 76 total students who take German. So I'm going to do 76 minus 14 minus 22 minus 9, and that leaves me with 31. So there are 31 11th graders who take German. And then I only have one more space to figure out, and I can do this by taking 72 and subtracting all of these from it, or by taking 32 and subtracting all of these from it. And it should give me the same answer either way. So if I do 72 minus 12 minus 19 minus 31, I get 10. So now my two-way table is completely filled out, and I can use the two-way table then to answer questions. All right, so for example 3, this shows the results of a survey done at a middle school, and students in 6th, 7th, and 8th grade were asked to state their favorite subject. So we're going to complete this table, and the first thing we're going to do to complete it is figure out, is there anywhere that I can right now just look at a row or a column that is almost completely filled out? Well, again, if I look at my total row, I know that there are 389 total 6th graders, 327 total 7th graders, and 358 total 8th graders. This box right here is asking me for the total that were surveyed. Well, if I know all of these were 6th, 7th, and 8th graders that were surveyed, to figure out this one, I would do 389 plus 327 plus 358. And when I do that, I get 1,074. So my total here is 1,074. And then from there, I'm going to do the same thing. I'm going to look at what I'm left with and what I can do with this 1,074. I know that I have a total of 1,074 students. And if I look at this row, there's only one box missing. So if there's a total here, then I can take all of these and subtract from the total to see how many students said that science was their favorite subject. So I'm going to take 1,074 and subtract 216, 279, 195, and 199. And when I do that, I get 185. So that means 185 total students said that science was their favorite subject. Again, I can use this. I know there are 185 total students who said science. So to figure out how many of those were in 6th grade, I'm going to subtract the 7th and 8th grade numbers from those. So I'm going to do 185 minus 45 minus 59, and that leaves me with 81. From here, I'm left with a row here that only has one number missing. So I know that there are 389 total 6th graders, and I need to figure out how many of them said math. So I'm going to subtract all of these numbers from that. So I'm going to do 389 minus 81 minus 113 minus 68 minus 59, and I'm left with 68. Now again, if I look at this column, I know that there are a total of 216 who said math was their favorite subject, so I need to know how many of those were in 8th grade. So I'm going to take away the 6th and 7th grade numbers from that. I'm going to do 216 minus 68 minus 71. And what I get for that is 77. Now that I have 77, if I look all the way over here, I have a total of 358 students who are in 8th grade. So I can use that to figure out how many of those said history. So I'm going to subtract all of these from 358. So I'll do 358 minus 77 minus 59 minus 84 minus 72. And what I'm left with is 66. Then I can figure out how many people liked history and were in 7th grade. So I know 199 people liked history, so I'm going to subtract the 6th grade number, which was 59, and the 8th grade number, which was 66, and I'm left with 74. Now over here for language arts, I know there are 195 total people who liked language arts. So to figure out the 7th grade number, I'm going to do 195 minus 68 minus 72, and I get 55. And then for the last one, there were 279 who liked reading. So 279 minus 113 minus 84 left 82 7th graders. If you're ever unsure and if you ever want to check and just make sure you did everything right, all you have to do is go back, add up everything in this row. It should equal 389. Do the same thing for the 7th grade row. It should equal 327. For the 8th grade row, it should all equal 358. And you can do the same thing for the columns. So if you add up all of these for history, they should equal 199. If you add up all of these for language arts, they should equal 195. So you can go through the whole thing and always check over your work to make sure you didn't make a careless mistake somewhere. All right, so for example 4, if you look at this two-way table, nothing is filled out. Well, that means we're going to have to fill it out. So it says at lunch, the entire 8th grade class of 320 students were surveyed to see if they were left or right-handed. So right there, it tells me the entire class was surveyed and there were 320 students in that class. That means I know by looking at my table, they're breaking this data up into boys or girls and left or right-handed. But I know that out of everybody surveyed, that total number is going to be 320. So that's going to come down here. It says only 36 students were left-handed. So that's not breaking it up into boys or girls. It's saying 36 total students were left-handed. So I'm going to go to my left-handed column, and I know that the total here is going to be 36. Then it says exactly 45% of the 8th grade class are boys. Well, I need to know how many are boys. So I need to find out what is 45% of 320. Well, if you remember back to when we work with percents, we always use our proportion part over whole equals percent over 100. Well, in this case, my whole is that there are 320 students. My percent is 45% out of 100. What I don't know is what is that part? What is 45%? So I can cross multiply here, and x times 100 is 100x, and then 45 times 320 gives me 14,400. And now to get x by itself, I can divide by 100 on both sides. So those would cancel and leave me with x, and I would be left with x equals 144. Well, let's go back to our problem and see what does that 144 actually mean. It said exactly 45% of the 8th grade class are boys. So that means I found out that 45% is 144. So there are a total of 144 boys. So I'm going to put that here because this is my boys row. And then it says 127 of which are right-handed. Well, there are 144 total boys, and 127 of those are right-handed. So now I have enough information, it looks like, to possibly complete my table. So let's look at what we can do. If I start with my boys row, I know there are 144 total boys, and 127 of them were right-handed. So to figure out how many were left-handed, I'm going to do 144 minus 127, which leaves me with 17. Well, from there, I can figure out how many girls were left-handed. I know there was a total of 36 students who were left-handed, and 17 of those were boys. So to figure out how many were girls, I would do 36 minus 17, which would give me 19. Now I need to look and see what else I can do. I can't really do anything with the girls' data because I have 2 missing spaces here. I can't do anything with the right-handed data, again, because I have 2 missing spaces. But I can do something with the total because I only have 1 missing space. I know that there are 320 total students, and according to this, 36 of them were left-handed. So to figure out how many were right-handed, I would do 320 minus 36, and that would leave me with 284. Well, now I have enough information to figure out how many of the right-handed students were girls. So I'm going to do 284 minus 127. And when I do that, I get 157. So that's how many girls were right-handed. Now I can figure out how many total were girls. I know 19 of them were left-handed and 157 of them were right-handed. So I can add those together and I get 176.